So one method is to put all of these in slope-intercept form, because then you can quickly see what's going on. And so you could have changed 3 and 4 from standard to slope-intercept. Just move your 2x over. You get negative 3y is less than or equal to negative 2x minus 6. Divide by negative 3y, and then this is going to flip, greater than or equal to 2/3 x plus 2. So then you can see what your sign actually does. These were obviously all the same line, and you can tell that from the graphs. What changed was, did you shave above it or below it, and did you have a solid or a dotted line? And that's really what you were looking for. So you could have done that with all of these. Same thing would have happened here. You would end up moving the 2x over, dividing by a negative, so you would have gotten y, and this would have flipped to less than 2/3 x plus 2. And so then you can see they're all different. You have a greater than, a less than or equal to, a greater than or equal to, and a less than. And then you can very quickly see which one goes where. All right, so they refer to distance and midpoint when you first open this section with maps. Now we think of linears as lines, not curves. When you talk about spherical geometry, you actually start talking about curves, which is what like latitude and longitude are. Those are lines that are a different type of line, not Euclidean, but spherical. And so the same is true, though, when you're measuring distance from city to city. You're really just taking one point to the other point and seeing how far away you are. Now, in the coordinate plane, it actually converts to something you're familiar with. The whole formula for distance comes from Pythagorean theorem, a squared plus b squared equals c squared, which we tend to remember really simply. But what they've done is they have just taken, I want to know how far this point is from that point. Well, if you look at that and you were to draw these lines connecting the x's and the x's and the y's and the y's, you see you have a right triangle. And what you're actually trying to find is the length of the hypotenuse. Well, the length of the hypotenuse fits into a squared plus b squared equals c squared, right? The two sides equals the hypotenuse squared. Well, how do you find those lengths? How do I find the length of this? Well, this is just the distance between the two x's. Subtract your x's. Well, how do I find this length? Well, this is just the distance between the two y's. Subtract those, right? And so the distance squared plus the distance squared equals the distance squared, okay? So that's how we come up with this formula. They subtract their x's and square it, a squared, plus they subtract their y's and square it, b squared. And that equals c squared. Well, since we're finding c and not c squared, in any Pythagorean theorem formula where you were finding the hypotenuse, you had to take the square root at the end. And so that is where the distance formula comes from. The distance is the square root of your x's subtracted and squared plus your y's subtracted and squared. It does not matter. Now, with slope formula, you have to do it in the same order, right? If you do y2 minus y1, you have to do x2 minus x1, right? It actually does not matter for distance formula. Why does it not matter which order I subtract these in any way, shape, or form? Why does it not matter what order I subtract?
Because you're trying to find the distance squared.
Right, but because you square them. So if I do 5 minus 2, I get 3. If I square that, I get 9. If I do 2 minus 5, I get negative 3. If I square negative 3, I get 9. Right? And so it actually doesn't matter. As long as you just subtract them and square them, you're going to get the right answer. I will say the biggest problem people get is they forget this is a plus, not a minus. So remember, it is a squared plus b squared. So while you subtract within it to get the distance between the two x's, you always add those two groups that you have squared. All right? So find the distance. It's really easy to find the distance when you have 2 points. You literally just plug them in. All right? So we're going to say the square root then of negative 4 minus 1 quantity squared plus 2 minus 7 quantity squared. Negative 4 minus 1 is negative 5, but I am squaring it like we have mentioned. 2 minus 7 is also negative 5 that I am squaring. So I'm getting the square root of 25 plus 25, which is the square root of 50. They can ask for this answer in two ways. They can say, exact. Exact means you need to simplify the radical. Or they can say rounded to the nearest tenth or hundredth or whatever. So depending on how they ask for the answer is how you're going to give it to me, right? If I want the exact answer, then you need to take this guy and you need to do your factor tree and get the exact answer. So the factor tree, 2 and 25 and 5 and 5. Remember, if it pairs up, it comes out of the radical. If it does not pair up, it has to stay in. So 5 square root of 2 would be the exact number. That is the exact number. If they say round to the nearest tenth, right, you would put this in your calculator and you would get something like this. Nearest tenth, though, just a reminder of rounding, that is your 10th place to round. You look at the guy next to it. 5 and above goes up, 4 and down stays. So this would actually round to 7.1. So I literally just want the middle of the x's and the middle of the y's, right? So to find midpoint, you literally average your x's and that's your x value. You average your y's and that's your y values. So you add here. Remember when you're averaging, you add everything up and divide by how many you have. So for the midpoint, I'm going to add my 2 x's and divide by 2. That is the x value of my midpoint. For my y's, I'm going to add my y's up and divide by 2. That's the y value of my midpoint, okay? It is a point. So distance is a one answer, right? Because you're finding the distance. Midpoint is an x and a y because it is a point, okay? And I say that because some people give me like one number for midpoint, which doesn't make sense. Midpoint is an xy. It is a point, okay? So you're averaging your x's, averaging your y's, and that is your midpoint. Find the midpoint. Well, this is really simple, and your midpoint can be negative. Your distance cannot be negative. You have squared 2 numbers, added them, and taken the square root. Distance can never be negative. Your midpoint can, because it's literally a point on the coordinate plane. So I'm going to plug this in. I'm going to add my x's. I'm going to say -3 plus 1, and that will be divided by 2. That is my x value. 4 plus 9, and that will be divided by 2. That is my y value. And then I just calculate it. -3 plus 1 is -2 over 2. 4 plus 9 is 13 over 2. If you can simplify it, simplify it. -2 over 2 is -1. 13 over 2 cannot simplify. You are welcome to leave it as an improper fraction. Just make sure you reduce it if you can. This would be your answer. -1, 13 halves. So this is actually pulling from some information that we talked about with the linear equations, okay? And a term from basically geometry, hopefully you remember. Perpendicular bisector. What happens if something bisects something? It cuts it in half. So if I'm talking about a line segment, where would I cut it in half? At what specific point? One that we just found. The midpoint, okay? So they're telling us we want you to go through the midpoint. And we want you to go through perpendicular, all right? So two things here. One, we need to know what the midpoint is. And they actually want us to use the example we just did. So we found the midpoint of example 2 here. Not the ones y'all just did, but the example 2 that we just did. -1, 13/2 was my midpoint, okay? So I know that that is the point that they want the line to go through, all right? So if you think about a coordinate plane here, we're going to do one really quickly so you can see it. Shrink it down a little bit. We have the line segment that starts at -3, 4, all right? So -3, +4 is right here. And then we have it ending at 1, 9, okay? So 1, 9 is way up here. This is my line segment. All right, so if I were to just look at this line segment, they want me to have another line go through this at a specific point. Well, the specific point that they wanted to go through is -1, 13/2, which is right at 6.5, right? So we figured out that the midpoint was right about here, okay? So we know the line that we're talking about is going to go through that point, all right? We also know that it's going to be perpendicular to this line. What do we need to know if we need to get an equation of a line that's perpendicular to a line? What do we need to know about that line? What do we know about perpendicular lines?
You know their slope.
We know their slopes are what specifically?
The negative reciprocal.
Right, so I need a point, which I have, and I need a slope to be able to figure out the equation. But I don't know the slope. And in fact, I don't know the slope of the other line, but they have given me 2 points of the other line, right? So I can definitely figure out the slope of this line segment using these 2 points, right? Do you actually have to use these 2 points to figure it out if I have it? You can just count, really. That's what you're doing. Change in y over change in x, right? So how far up am I going? Which is really what you're doing, by the way, when you do the slope formula, okay? Is this going to be a positive or a negative slope? Look at it. Positive or negative slope? It's going to be a positive slope, right? My y's go from 4 to 9, right? 4 to 9. So if I were to do counting, which is basic subtraction, right? If I were to count from 4 to 9, what would I get? How many up would I go? I would go 5, right? Which is the same thing if I subtracted my y's, by the way. 9 minus 4, okay? Slope formula. And then I am walking from -3 to +1, right? How much did I walk there? 4, okay? Which, by the way, is what happens when I do 1 minus a -3, right? So that is the slope formula. So I do know the slope of this line. So I have a point that I'm going to go through, and I know the slope of the line that I'm going to go through, right? That's not the slope I need to use, though. What specifically did they say about this line that I'm going to use? It's what? It's perpendicular. So what do I need to do to this slope? I need to flip it, so it's going to be 4 over 5. And I need to change the sign. It was positive, I need to make it negative, right? So now I know the slope that I'm going to use. And so I'm going to take this slope right here, and I'm going to take these numbers right here, and I'm going to come up with the slope-intercept form. It's also important that I remember what slope-intercept form is. Y equals mx plus b, all right? So the only piece I'm missing actually to fill this in is the b, and I'm going to use those 2 points to figure that out. So my y value is what? What's my y value of my point? 13/2. What is my x value of my point? -1. And so now I'm going to solve it. -4 and 4/5 and -1 just give me a positive 4/5. 4/5 plus b equals 13 halves, right? I'm gonna run out of room, so we'll scoot all this up. He is not scooting up well. All right, subtract my 4/5. Subtract my 4/5. What do I need when I'm subtracting fractions? Common denominator. What is my common denominator between 5 and 2? 10. So I need to multiply this by 5, and I need to multiply this by 2, right? 5 times 13 is 65. 5 times 12 is 60, right? And then we're minusing 2 and 4 give me the 8 over 10, right? So 65 minus 8, where am I? 57, right? Over 10. That is my b. That's what I solved for, right? I know there's crazy fractions, but basically you're just solving for b. You did it on your quiz for me, okay? Am I done? They want the slope-intercept form of the equation. Am I done? No. I have my m and I have my b, but what do I need to do to those two? I need to plug them in. My slope-intercept form of this equation is going to be y equals, what was my m? Negative 4 over 5. X plus what was my b? A hideous 57 over 10, right? That is going to be the line that goes perpendicular through this guy. And so if you were to look at this line, and I were to actually graph this line, it would go at a right angle actually through this point right here. That would go through the midpoint and look like that. And you'll see it actually does cross at about 5 7/10 is where it would cross. So a little past 5 there.